You see this topic and this topic in pretty much every physics book, waves and sound. Now, these two ideas are really closely related to each other. In fact, sound is a kind of wave. Now, you have studied these ideas quite a lot of times in theory, but maybe you have not seen any practical significance of these ideas. Well, in this video, I'll perform a practical demonstration that reflects those ideas in a rather funny way. So let's get started. Well, this demonstration is called singing pipes or sounding pipes. What I have here is a Bunsen burner and a copper pipe. This is a copper pipe that is about 36 centimeters long and about 4 centimeters in diameter. And what I do is I cut a metal mesh. This is a metal mesh. It is a pretty heavy gauge. And I cut a piece of it, and what I do is I fit that piece of mesh in this pipe about here. I put this is a rather good looking piece, and I put this piece into this mesh in about here, about 10 centimeters from this edge. And what I do is I heat that metal mesh like this. Well, this is producing a rather funny noise, rather funny sound. This is a pure frequency, a pure note. Now, what it is doing here is when I heat this wire mesh, the wire mesh gets actually red hot. And what it does is it heats the air surrounding that metal mesh, and the air starts to flow. We all know that hot air rises. So hot air rises up and it creates a really streamlined flow so that air column inside that pipe will resonate and generate a particular frequency of sound. This is the demonstration of stationary wave and sound wave, to be precise. Now, this frequency, this is the characteristic frequency of this length. This is 36 centimeter length. Well, I have a formula here to predict that what frequency will be produced by this pipe. Well, this formula is for open system. We can see that the pipe is open from this end and open from this end also, and it reflects somehow the mathematical expression involved in a practical demonstration. So Fn equals Nv divided by 2L, where F represents the frequency we get from this pipe and N represents the number of harmonic. We are pretty interested in first harmonic, so we put N equals 1. The velocity of sound in air, which is represented by V, which is equal to 332 meters per second, divided by 2L, where L is the length of pipe. Now, what I can do here is I can find the length of this pipe with that particular frequency. So what I do is I have here an app called oscope or oscilloscope, and this measures the frequency generated by this pipe. So I'm hitting it again, and I will record that frequency so that I can see it in this app. This is about 503 hertz. 503 hertz. Now we can solve this equation F equals Nv divided by 2L for the unknown L, so that we can find the length of this pipe without actually measuring it by knowing that particular frequency, which is somehow the mathematics in action. Now that's all for this pipe. Now I have here a second pipe. This is rather small, having a smaller diameter than this. This also has that particular wire mesh lodged here, about here. So I hit it. Now this pipe is also producing the sound wave in that particular region. This actually gets quite hot. I rather have to put a glove on. So I will record that frequency again. Is about 510, 520. So this is because those two pipes are exactly same in length. They're slightly off, but quite equal in length. So from this formula we can see that diameter do not affect the frequency, because diameter is not actually appearing in the formula. The frequency that is generated by this pipe is exactly characteristic to its length, is only dependent on its length. Diameter do not play a huge role in this frequency. Now what I will do is I'll excite this beast. I'm pretty excited about this. This pipe has also a wire mesh about here, and I'm hitting it. Let's see how this sounds like. This is rather loud. I'm doing it one more time. Notice the acoustic life. I will repeat that same procedure for this. Now what I will do is I will not tell you the length of this pipe. So we can solve that equation F equals NV divided by 2L for this unknown L. This is also an open system. And what we can do is we can solve that equation for the unknown length L. Now I will record that frequency in the app. So let's see. This is generating about 310. Now put that in this equation and let's see we got it right. So what we've learned from all of this is that science is actually a lot of fun to do, and we have to do some experiments, some real life experiences, so that we can taste it more better. We can deeply understand those ideas, and involving mathematics will help us to understand those ideas more better. And I thank you for listening.